Alright, we're moving now on to the difference between mass and weight, which is something that's commonly confused around society. Scientists use those words in very specific ways, whereas the general public use them interchangeably. Mass is actually measured in kilograms, and its symbol is a lowercase m. So, put that there. Whereas weight has a symbol of force. It could be force W, or it could be force G. So it's actually a force, so it's measured in newtons. Now mass is how much matter an object has, or how many atoms an object has. Whereas weight is, so it's how much gravitational force is applied to an object is what weight is. Whereas mass was how much matter the object has. So if you take an object to the moon, you're not making it any smaller, you're not giving it any less mass, so the mass value on the moon will be the same as what it is on Earth. However, the gravitational force on an object when it's on the moon is significantly less. And that's determined by the mass of the planet that you're on. So for Earth, it just works out that our strength of our gravitational field is 10 newtons for every kilogram of mass. So it's a nice convenient number. On the moon, it is 1.6 newtons for every kilogram of mass. And if you go to Mars, it's 4.0. So it's all dependent on the amount of mass of the planet. So our planet is the largest of those three objects. Therefore, we have the largest gravitational value there. Now, here's our ambulance. We're going to try and work out what the length of this force vector is pushing down. That is its force weight. And to do that, we're going to be using our force is equal to MA formula. So we put in our value of 2200, and instead of A, this formula can be modified to be force weight is equal to mass times G, which is the specific strength of gravity value. So we're going to put a 10 in there. So because this ambulance is on Earth, and it just becomes 2200, and we add one more 0, and that there is what the force weight is equal to. Now, if this ambulance is just sitting stationary there, that will tell you that the support force from the bridge or the ground, whatever it's on, is exactly the same, 22,000 newtons. So you got the same up and the same down. If this bridge was to break and our force support was changed to 0, now that is gone, then what would happen is that this ambulance would accelerate towards the ground at 10 meters per second. And that's true for all objects if we ignore air resistance. So it doesn't matter if you were to ignore air resistance and you dropped a feather versus dropping a lead sinker, they would fall at the same rate. Now you'll think that looks unusual because it's very hard for you to imagine no air resistance. But if you did them in a vacuum where there is no air for the objects to crash into, they both fall at the same rate regardless of mass. It's because this 10 newtons is applied per kg of mass. So mass has no effect on falling rate. Alright, we'll do a quick calculation to find out what the weight force of our ambulance will be on the moon now. So same formula, force weight is equal to mass times gravity. Remember, mass doesn't change just because we've taken it to the moon. It's still 2,200. But the gravity on the moon is much less. So we're just going to be timesing it by 1.6. Alright, so you can see that on the moon, it's only 3,520 newtons. Mass is the same, weight is significantly less.